Great. Well, welcome everyone to our panel, Scaling Showdown, Optimistic or ZK Rollups. It's been a really exciting time for scaling in the whole blockchain space. We've seen so many different projects launch, so much activity happening. So I think we just wanted to take this session just to kind of learn a little bit more about the two main camps. You know, we've got zero knowledge, and we've got optimistic rollups, and just learn about some of the advantages of each of the different types, some of the challenges, and some of the kind of things that we can look forward to in the future, and kind of the innovations and research that any builders in the audience and watching at home can look forward to. So yeah, let me just briefly introduce our panel. So we have Ohad from StarkWare, we have Jordi from Polygon zkEVM, we have Anuja from Arbitrum Foundation, and we have CC from the Ethereum Foundation. So let's kick things off and set the scene a little bit. Ohad, could you just give us a brief overview of how zero knowledge can be used for scaling a blockchain?
Sure. So basically, scaling blockchain like L1 is problematic, right? Because essentially we have a lot of full nodes, and we want all of them to be sure that the blockchain is secure, which means that naively they need to re-execute all the transactions and make sure that the state is good. So ZK and knowledge proof are basically this magical tool that instead of just telling the full nodes what the transactions are, we basically work a bit harder and generate a proof. And then they in turn need to work 100,000 times less to verify all of those transactions compared to naive execution, right? So you have this layer 2 where a lot of transactions happen, and just with a fraction of the effort, you can verify everything on chain.
Perfect, great. Anything to add there, Jordi?
No, yeah, at the end is what he said. It's the succinct part of the snark of the zero knowledge. Yeah. This is what makes it. It's what allows you to verify a computation in much less time than what it takes the computation itself. And this is when you go the consensus. That means that not everybody has to compute everything. They just verify the proof. And this is what really allows us to scale blockchains.
For sure, great. Anuja, could you just give us an overview of how an optimistic rollup works?
Yep, sure. So generally users, if they do any transactions on layer 1, so basically optimistic rollup and zk rollup both are for scaling Ethereum, scaling any transactions which are happening on layer 1. So let's say all the transactions which are happening on Ethereum, now how to scale those, right? Basically computation, data, and execution, those are the problems on Ethereum. So basically ZK and optimistic, both they scale for these three things, right? So optimistic rollup, what they do is parallelly just imagine that in parallel to Ethereum, any layer 1, the optimistic rollup blockchain is running. All the transactions which are happening on optimistic rollup, those are periodically gets batched. Basically batched, it means it aggregates all the transactions in a very powerful manner and then compress that data and then put on the Ethereum blockchain, the main blockchain. So this is how the computation and execution which was supposed to happen on Ethereum, now they're happening on other chain, which is an optimistic rollup. And only the call data, which is suppressed data, which is enough for anybody to prove that this data is valid or not, which happened not on Ethereum, but which happened on the optimistic rollup. That data is again put back on the Ethereum main chain, which is how these rollups, optimistic rollups, are backed by the security of Ethereum. And all the transactions that happen, because it happened on rollup, that's why we achieve the scalability on optimistic rollup. Now, optimistic rollup, they're a bit different compared to ZK. They assume that all the transactions that happen on optimistic rollup, those are correct, and the data which is put on Ethereum, that is sufficient for anybody to prove later on. We give some amount of window for any challenger if they think that this data, let's check the data if that was valid or not. Then if anything malicious activity happened on that data, then anybody can prove it. And essentially the rollups, optimistic rollup, they assume the data was correctly put, and that's how it moves.
Great. And how long is that kind of window for people to challenge the transaction?
Currently on Arbitrum rollup, it's 7 days.
Okay.
Yeah.
But that's kind of standard for optimistic rollups.
For standard rollup,
Okay, great. So could you, Anuja, just discuss a little bit more about Arbitrum's specific approach to optimistic rollup? Because I know that there are a few other projects that have launched optimistic rollup. So how's Arbitrum different to this?
Yep, sure. So Arbitrum is an optimistic rollup, but there are many optimistic rollups as well. Now, it is different in some technicality. The design is a bit different than other optimistic rollups. Let's start from how do you compress the data on optimistic rollup? So you have to be very efficient in compressing the data because you want to only have very minimal data space on Ethereum, right? The less data space you cover on Ethereum, that's how you further scale for the cost. So Arbitrum's compressing data, it works on Nitro technology, which is very sufficient. It compresses the data in a very, very efficient manner so that it only takes a very minimal amount on Ethereum, which is, again, sufficient for proving. That is one difference. Second difference is, let's say, during that 7 days window, if anybody wants to challenge that for that data batch, then the fraud proofs are also available on Ethereum. Arbitrum optimistic rollup is the only rollup right now in the space which allows the fraud proof generation. The fraud proofs are live on Arbitrum, which is not available anywhere else. So these are the two very high level, I would say, technical difference for Arbitrum. And yeah, apart from that, tooling ecosystem sides are also different.
Great, all clear. Jordi, could you just talk to us about Polygon zkEVM? What are you able to do on Polygon zkEVM that makes you unique compared to other zkEVMs out there?
Well, right now we are the only zkEVM that's running on chain, that's in production, running in production, and it's zkEVM. I mean, it's an EVM itself with a full prover, fully verifiable. I mean, you can, and this is probably what makes unique. But still, and the zkEVMs, the cool thing of the zkEVMs is that you don't need a special tooling to build on top of that. I mean, if you know how to create a smart contract, compile, and deploy it in Ethereum, you use exactly the same tooling, you use exactly the same thing, and you just connect MetaMask to the zkEVM, and you are there. So the only difference with Ethereum is that well, it's in the zkEVM is going to be cheaper and the throughput is going to be higher, but it follows exactly the same rules that Ethereum is doing. This is the Ethereum virtual machine, the EVM. That's the core of Ethereum.
Okay, great. And I think that's a perfect point to bring Ohad into the conversation because I know that StarkWare doesn't use the EVM. You have your own, it's called Cairo, I believe. What was the decision making behind that, and kind of what advantages does that offer builders looking to deploy on StarkWare?
Sure. So, like the initial motivation to be, a zk rollup but not a zkEVM based one, is that essentially we want everything to be as efficient as possible, and the EVM architecture wasn't designed with the thinking that one day someone would use it to prove, right? It's like it's a new technology and it deserves like dedicating tooling and language that would make it more performant. I think that along the way we learned a not less important motivation, and this is that we don't need to be compatible with the way Ethereum does things with referred to transactions. For example, there is a EIP 4337 for account abstraction, right, that Ethereum recently adopted. So we were able to came with account abstractions a bit sooner and as a first level citizen. So you don't need to use like a layer, right? And this is also thanks to not being fully EVM compatible.
Right, great. Sorry.
Here, maybe I want to say that the fact of being EVM compatible is that we get, for example, the 4337 for free. I mean, we don't even, when we started to design the zkEVM, we were not planning to do the account abstraction. And now we have account abstraction for free because we are Ethereum compatible. I mean, and all these, here we are taking all the traction that Ethereum has, all the ecosystem that Ethereum has, all the innovation that Ethereum has, all the smart contracts, everything that's running in Ethereum, they go strike forward without having to do anything else. Okay? This is, and I think this is really important because I think this is also in Arbitrum is also happening, and I mean other the EVM rollups. This is the big difference, and this is what allows to as Ethereum community to really grow together and to have synergies between the different efforts that are happening on Ethereum.
Yeah, I mean, I think that it's two sides of the same trade-off. Basically, we also learned the account abstraction from the Ethereum community, right? So there is ID sharing here. We are not constrained, but we also don't get stuff for free.
Right, got it. And CC, I just want to ask you, just from your perspective from the Ethereum Foundation, I know that you're kind of a little bit more focused on zero-knowledge technology, but just generally, how do you feel about the state of Ethereum scaling right now? Is there a lot more to do, or do you think we're kind of very nearly there where Ethereum is going to scale?
Yeah, thanks for the question. I think we are on a very good progress. Like, I think the Ethereum L1 is trying to provide more like data availability with all the tank sharding and EIP 4844 efforts. And also, I think we are getting like zkEVMs, we are getting optimistic rollups at a very fast iteration speed. And then, although there are some challenges, like I heard we have the training wheel problem. Like currently we still haven't have a like real decentralized sequencer, and also like any EVM incompatibility is also an issue. Yesterday I heard an auditor, he said like people would imagine they can deploy the contract into any L2 and then expect it to run, but like it turns out it would introduce a lot of bugs in the contract. So I think, yeah, that's the challenge I see.
Okay. I mean, that's a good point to talk about some of the challenges, and I think decentralization is a bit of an elephant in the room when it comes to rollups. So I think it'd be good to hear from each of you from the rollup camps. How are you sort of seeing decentralization? How are you kind of managing that on your roadmap? Ohad, it'd be great to start with you.
Yeah, I think that decentralization for zk rollup is a very unique and fascinating problem. Like we see a lot of L1s decentralizing. But with rollup, you have the extra layer of which is the prover, right? So we need to decentralize prover as well. So this create the needs for like an entirely new, maybe not, we can base ourselves on existing protocol, but we need to do a lot of new novel things. So in the past year, we had countless discussions internally in StarkWare in how to do it, including getting external help from people that are well-versed in the decentralization community, and we continue to work with our community to see what trade-offs, right? Because the decentralization for like 50 nodes or like 50,000 nodes is a very different kind of decentralization and trade-off, and we don't know what our community would appreciate more. And I think we're currently concluding, I would say, the design phase that have been like more than a year in the next few months. And we first want to make StarkNet a like scaled and very cheap place to trade on, even a centralized manner. Before we turn to decentralization, which is like hopefully starting next year.
Great. Jordi? Yeah,
well, here, decentralizing the prover is important, but I think it's much more important decentralizing the sequencer. Mm-hmm. At the end, a prover, the only thing that can do is to prove. So it can prove or cannot prove. So as far as there is one person that's proving, it's fine. The problem is more in the centralization, in the sequencer, because the sequencer has a lot of power. It's equivalent to a miner in a blockchain or to a validator. Somehow they have this right to do front runnings and all these root map. And, I mean, they can do a lot of things. And they can even censor transactions, okay, which is problematic. I mean, say, okay, your transactions, they are not going to happen, and maybe your funds are locked. Here, from the decentralization perspective, there are different levels. For example, we are implementing what we call forced transactions. So in our case, for example, we cannot, nobody, the funds of the user, they cannot be censored. I mean, the user at the end, they can pay maybe a L1 transaction saying, force this transaction, and then the sequencer has the obligation to pay this transaction. This is it's a level of centralization. It allows you to have this censorship system, but it's not, I would say it's good, but it's not enough. I mean, because somehow with this mechanism, what we are doing is kicking out people from the system. I mean, if the decentralization have the right to tell you out, and you don't like it, out, okay? So it's not, I mean, okay, you go out with your money, but you are limiting who's using. We are not creating a universal, system. Okay, we want to build systems that are universal, that don't depend on a centralized individual in any case. Okay, and here the decentralized sequencer is really important. In the case of Polygon, we developed what we call the proof efficiency. Proof efficiency mainly is using the layer 1 as a sequencer. This is fully decentralized. I mean, it's a fully decentralized system. The problem of this is that the limits, so you have the same limits that the layer 1. I mean, you cannot get better, you cannot, if you're running on top of layer 1, you cannot be better than the layer 1 that you are running, okay? What we can do, and here the problem is that, for example, there is kind of a competition here, and for example, in the finality on the transactions, okay? And we see that a lot of the applications, they don't care a lot about decentralization, about security, and they care a lot about the finality for their specific applications. That means that the consensus layer of Ethereum is not good enough, okay? And here, the idea is to add another consensus layer, probably with different parameters that Ethereum has. I mean, with different, you see the blockchain trilemma maybe with a different place in the, but that's a temporary consensus until this transaction is set in the layer 1. Okay, right. So it's perfectly possible, and here is where we are working in Polygon, working in what we call it decentralized sequencers, that at the end is a consensus mechanism, a sequencer that has a consensus mechanism that decides who's sequencing, and this consensus can be with different parameters in this blockchain trilemma. Just say that a centralized sequencer, it's also a consensus mechanism. I would say it's a dictatorship consensus, because I mean the consensus is what the centralized says, but it's a consensus itself. Right. So the idea here is to replace the centralized sequencer with another consensus that is much better for real applications. And here is what we're working on.
Okay, that makes sense. And then Anuja, just from an Arbitrum perspective, how are you seeing decentralization? Because I know obviously, the Arbitrum Foundation recently launched the DAOs, kind of, yeah, both from like a technical perspective and also from a social perspective. How are you seeing decentralization?
Yeah, sure. So I can break down the answer in 3 parts. First of all, because optimistic rollup is actually putting the fraud proof on Ethereum. So now this is a bit decentralized anyway, right? Anybody can challenge that transaction on Ethereum. And this is how it proves, right? It is still secured by the Ethereum. So that is one part. And second part is, we can't also afford, right? All the transactions that we put on Ethereum, anybody can challenge, and then we are hopeful that all the transactions that we put from our optimistic rollup to Ethereum are all pre-assumed that these are optimistic. So we really don't encourage more and more malicious transactions, right? So that's how we also optimize for how do we batch the transaction on optimistic rollup. So there are 2 parts here. First is how do we compress the data on optimistic rollup, and how do we make sure that the data that we are putting on Ethereum, those are actually at least mildly correct. So for that, what we do is there are verifiers on Arbitrum optimistic rollup. They verify the data once the sequencer batches all the transaction and push it to the Ethereum blockchain. So on Arbitrum optimistic rollup, the difference compared to other rollup is that sequencers are only there to batch the transaction, not to actually validate the transaction. There are verifiers, there are validators, which are bunch of validators, and we're also working to make those validators publicly available. So there will be in future, there will be a place where anybody can apply to become a validator, verifier on optimistic rollup, and they can basically verify the optimistic rollups transactions. And sequencers' job is to only batch the transaction, order the transactions. So that will also in future, right now there are only few sequencer on optimistic rollup, but the plan is that there will also be a bunch of sequencer, like a group of sequencer. Consensus will be there. Everybody will decide that who will become the sequencer for this batch. So that part also will be validated. So I think these 2 major steps on the technical perspective will again push the Arbitrum optimistic rollup again near to the decentralization. And the third part of becoming the decentralized rollup is the major DAO. So Arbitrum recently announced that Arbitrum is now in the hand of community. So what it essentially means is that any technical upgrade that happen on Arbitrum rollup will be elected and chosen by the Arbitrum community, which is the DAO. So literally, this is self-execution DAO. Let's say community decided that let's upgrade this particular technology, or let's say anything, any kind of upgradation on Arbitrum rollup will be completely chosen by community, and they don't have to wait for anybody. This is self-execution DAO. If they decide, if they get the voting, then execution happen automatically. So I think this is the very biggest step from Arbitrum side, which we took from the, to get near to the complete decentralization.
That's very interesting, handing technical upgrades to the community. I mean, it'll be interesting to see how that kind of pans out as well. Ohad, so from a state of kind of tooling and infrastructure on StarkWare, I know obviously you're not EVM compatible, so you kind of have to do a lot of that by yourself. What's the state of tooling and infrastructure in StarkWare, and how are you supporting builders, to build dApps on your platform?
Yeah. So yeah, the negative implication of working with our language is that we basically need to develop a lot of toolings from scratch. But we work with very competent external teams on creating the equivalent experience for what Ethereum developers are used to. So like instead Ether.js, we have StarkNet.js. We have like a Protostar, which is mimicking the testing utilities of Foundry, and so on and so forth. Obviously, as you can expect, StarkNet is much newer than Ethereum. All the tools are in a bit more infant state, I would call. Like they are just starting, and not just started, but some key features sometimes still miss. And we use our close connections with a very strong dev community to get inputs on what's missing and what can we do better and where we should invest more, to really be in a few months to year place, in a place where the tools are different, the low-level detail differ, but the developers don't really feel the pain of missing out on all the Ethereum dev tools.
Great. So yeah, I just want to move on to kind of the scaling and innovation and research. CC, I know you mentioned EIP 4844 coming out. I think you mentioned next year maybe. Is there anything else in the kind of long-term Ethereum future that we can look forward to in terms of scalability?
Yes. So, I think it might be best to let me summarize all the scaling. There are three elements in the blockchain computation. One is the computation execution, and the second is storage, and third is data. And now Rollups brings the computation and storage load of the L1, but the Rollups still need to consume data on L1. So the full sharding, especially we're talking about data sharding here, trying to provide as much data as possible to make Rollup more cheaper and more useful. And also for the other part, I'm seeing the type 1 zkEVM. So with type 1 zkEVM, we could have a better bridge to the rollup, and also we could build better light clients. So hopefully in the future we could verify Ethereum L1 block on your mobile devices just with a very cheap zk proof.
Okay, great. And then Jordi, I know that we have a lot of these different rollups, some of them EVM, some of them not EVM. How are we gonna? How are these different rollups going to communicate? Is it how difficult will it be for a non-EVM and an EVM rollup to kind of communicate and bridge from each other? Are we going to see that in the future quite a lot, or is there always going to be this element of friction for end users?
Here, the bridging between rollups. When we talk about bridging, I mean it's the thing here is the security, okay? And the problem is when you are bridging between rollups is that the security set by the less secure one. I mean, if you are connecting 4 rollups and you have one that's insecure, the 4 rollups are insecure. Okay, so here we have like a kind of frontiers between rollups that that they have the security. If you are in one of these, let's say, constellations of rollups that you are assuming that this security, this is, I mean, and in general, this is going to be, for example, they can be, for example, a single proof, or so a proof system can hold a constellation of rollups. Okay, so this is the case of, for example, in Polygon. In Polygon, we're going to build a set of rollups that they are going to share the same proving system, so they will share the same security. So all of them, they're going to be equilibrated. Okay, I mean, this could be extended if we assume that 2 proof systems are the same. Okay, if we're in the same security, then breach can go really fast, especially in zk rollups. Because in zk rollups, I mean, when you put a proof, that's you don't need to wait 1 week. You can, and this transfer between rollups can be immediate, and we are thinking that the proof can be done maybe in 30 seconds, 1 minute in between rollups, and this is really fast. At the moment that you are changing to different constellation, okay, then you need to go somehow to layer 1. I mean, you need to do you need to do kind of an exit and an entry again, and this can be slow, but still much faster than if you are communicating, for example, between optimistic rollups. So zk rollup to another zk rollup can go relatively fast because the exit can go fast. That if you are, I mean, if you go to if you are exiting from an optimistic, maybe you need to wait 1 week in order to go to another one. But this allows super interesting things because this allows composability between rollups. I mean, just you can be in a private chain that's calling a public chain, doing some swap or some DeFi thing, and then you're going back to a private chain, and this can be done in 1 minute when you are inside.
Great. Okay, that makes sense. Ohad, just wrapping things up then on this kind of section, what can people look forward to in StarkWare over the next few years? You know, how are you going to be helping builders sort of build applications?
So like next few years is like an eternity. Let's focus on what remains from this year. So we have 3 major upgrades that we'll plan to do in Stark this year. The closest of them is basically boosting up the throughput of the network. We'll be at 100 or more transfers per second after this upgrade, which is in a few weeks' time. The next version is all about targeting data availability. Currently, data availability is more than 90% of our cost. Like proving and state updating is less than the other 10%. And we want to offer developers more flexibility and basically give up the data availability whenever it makes sense without hurting the security of those that chose not to give up on it. And the last version we planned for this year is basically adding a mempool. I think mempool is a must-have for any capital-efficient systems. We see it with blockchains before. And yeah, so we plan to have it as well.
Look forward to seeing that. I know we're nearly out of time, but I kind of wanted to end on a little bit of a positive note. I know sometimes people think it's optimistic versus zk rollups, but you know, is there a world where these 2 worlds sort of meet? You know, will we ever see a hybrid optimistic and zk rollup? Is such a thing kind of possible from a technical perspective? Anuja, is there anything kind of, is there any truth in that?
Yeah, it's a good question. I mean, right now, we all are trying to scale Ethereum in all the way possible, right? All the teams are very much research focused and everybody's trying to scale Ethereum the best way possible. But I think with the time, there will be a time in few years that nobody will even know what technology they're building on, right? They're just scaling Ethereum, they're building on a blockchain technology. Now, a few years back, I think in 2017, our Arbitrum team also wrote an entire research paper on zk, how basically zk is the technology for scaling Ethereum, even before launching Arbitrum as an entire rollup. So I think from the research side, our team is also working on all the possible solutions to scale Ethereum. But from Arbitrum side, right now, for the time being, looking at the user demand, we really want to just again improve the optimistic rollup as of now, because the underlying design of optimistic rollup for Arbitrum allows for a multiple innovation, like tremendous innovation here. So as of now, the near term, I think we are still improving the optimistic rollup on Arbitrum, but for the future, definitely we will have a research team, and we can see if we can include some part of zk rollup to our optimistic rollup as well, and we can also explore the tooling side of it. Like how do we make the optimistic rollup and zk rollup talk to each other and then come to the conclusion where it's a good place for the end users. It's not competing the technology, so that's good.
Perfect. Well, I think that's a great place to leave it. Thank you to my amazing panel, and thank you all for listening.